Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to my discussion for today. So we're going to look at a concept under projectile motion, and that is finding the maximum range angle of course over which this projectile has been launched. And of course, we're going to use the previous video we had done on the concept of horizontal range in trying to find this particular kind of angle that is going to be the maximum range angle. So we're going to borrow from our last discussion on the concept of horizontal range. And this, of course, is going to be the maximum distance which is going to be traveled by a projectile before returning to the ground, or the horizontal distance that is going to be traveled by a projectile before it's going to return to the ground. And we had derived this one from our equation, kinematic equation, which, of course, we had given in terms of the initial speed, of course, together with the difference of g squared. So I presume that we understand from this specific case. So we have decided that for a projectile, we're going to measure its distance along the horizontal line using that x-axis. And therefore, if that is going to be the path of travel of that specific projectile, we're going to consider the velocity at this specific point for the x and y component given in terms of those specific values, x and y naught. So we have depicted the initial velocity of launch using that one, and then we said that this projectile is going to travel to a specific distance, which is going to be having a maximum point at that particular point, and then we're going to have the velocity along the y component in this specific case given as a 0, whereby we're going to have the velocity along the x component in this case given as the velocity of travel given in terms of v. So in this case, we're going to borrow from that specific discussion. But I said that for us to find the distance along this x-axis or the horizontal distance along traveled by the projectile before returning to the ground at this specific point, we're going to have two initial points of this specific contact between this trajectory and the x-axis, whereby these are going to be forming a value of the points of y is equivalent to 0 at t is equals 0. So let's assume that this projectile was launched at this specific point at t is equals 0. Then the value for y along this line is going to be 0. And at this specific point whereby we are going to have the time at t equivalent to that specific value when all the, of course, motion has occurred, or the whole trajectory has been covered, we're going to have the value of basically y is equivalent to 0. So we can use this second condition for us to evaluate the concept of this specific kind of a motion and find the equation for range, which is going to assist us, of course, find the maximum angle with which this projectile is going, or the maximum range angle which this projectile is going to be launched. And from our previous discussion, therefore, we came up with the formula for range given in terms of the square of this initial, of course, of this resultant velocity, which I've given in terms of v naught. And of course, we're going to have this given as the sine over 2 theta given as that one. And this is going to be all over g. So I've decided that theta is going to be the launch angle, of course, which is going to be given in this particular case as this particular angle. And therefore, this is going to be assisting us in trying to find the maximum range angle with which we're going to describe this one in terms of theta. So for that specific description, then therefore we're going to see that for a given initial velocity v naught, then the maximum range, of course, can be given in terms of this specific description. So we're going to have this initial velocity given in terms of v naught. In this case, we're going to have range maximum given in terms of dr over the theta. So we are going to differentiate the range with respect to, of course, theta, and this is going to give us the value of 0. So basically, we're going, that one implies that we're going to find a derivative, a first derivative of this range with respect to the angle, and therefore this is going to give us a range maximum at this point given in terms of d over the square of this, of course, v naught, the sine of 2 theta, of course, all over g. So this is going to be d, and then we're going to have this one all over g, and of course we're going to have this one as a d theta given as that one. It's going to be giving us a particular value, whereby we are going to see that this basically is going to be the derivative of v with respect. So we're going to have that one. So basically our numerator in this case is going to represent the concept of a range, as I've said, and we're going to do a derivative with respect to theta given as that one. So this is going to imply that we are going to have these specific values. So according to the laws of derivatives, we're going to take the constants out, thereby implying that dr over d theta is, of course, can be found by having this one as. So this one is going to be a constant, of course, which we are going to give as a v naught, and that, of course, we're going to have this numerical value of 2 given as that one, and we're going to find the derivative of this specific function over the sine, of course, which is going to be the cosine over 2 theta. So we're going to have the cosine over 2 theta given as that one, and then, of course, this is going to be all over g, and we decided that this specific value for that, of course, derivative for the maximum range is going to be given in terms of 0. So we shall have this one given as 2 the cosine over 2 theta divided by g. And this implies that we can have this particular value of g multiplied on both sides, and therefore we're going to have a 0. So we're going to multiply g on both sides in this case for simplification, and then we're going to have this one given as v naught is equivalent to 2 the cosine over 2 theta given as that one. So if we try to look at these two specific values, if we consider them to be coefficients of the cosine over 2 theta, then therefore these are not going to be equivalent to 0. And therefore we are going to consider the second case for the trigonometric function, which is going to give us the value of 0, and this is going to be values over pi over 2, which we can give in the first case, which is equivalent to 90 degrees angle. So in this case, for us to find that specific angle, we're going to have this one given in terms of the cosine over 2 pi is equivalent to 0, and therefore we can have this one as 2 pi is equivalent 2 theta, that is 2 theta is equivalent to 90 degrees, further implying that theta basically is equivalent to 45 degrees. So in this case, if we are trying to look for the angle of launch, which is going to be a maximum, using this specific concept of for a maximum range, the derivative with respect to theta of a range is equivalent to 0, and therefore that equation is going to give us this particular evaluation, whereby we're going to make theta the subject of the formula, and that's going to give us the maximum range angle with which this specific projectile can be launched, of course, to achieve this maximum range. So I presume that we have understood. Kindly check our description boxes for various links of other videos. Subscribe and engage us in the comment section, and also ring that notification bell to be getting updates on our various uploads in maths and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.